In this video, we're going to talk about um, electrical elements that store electrical energy. So these are the capacitors and the inductors. Now, let's first cover capacitors. So what are capacitors? So capacitors are passive elements that are designed to hold electrical energy in the form of an electric field. So these capacitors are made of two conducting plates that are separated by what we call a dielectric material. So this material can be made of paper, oil, mica, plastic, ceramic, or even air between the plates. Now to access the capacitor, we attach conducting materials or terminals on the plates. Now, when we connect a capacitor to a voltage source, so we connect the plates to the source, what happens is that charges accumulate on the plates. That is proportional to the voltage that is being applied to the plates. Now, the constant of proportionality there, uh, if we define the equations to be Q equals CV, C there is the capacitance of the capacitor, where it has a unit of a basic unit of farad. A smaller unit is sometimes used, and more popular unit is the microfarad, or sometimes we have the picofarad or the nanofarad. Capacitance is actually a function of the physical design of the capacitor. So C is actually proportional to the area of the plates and the distance between these plates. The constant of proportionality there is what we call the permittivity of the material between the plates. To so if we have a larger capacitance, that what that really means is that the capacitor can hold more charges on the plates for a given applied voltage. One plate being positive and one plate being negative. Now these charges on the plates actually creates an electric field that holds the energy stored on the capacitor. Now, when we withdraw the applied voltage on the capacitor, this electric field remains, the charges on the plates remain, so therefore the electric field also remains, and of course the energy as well. We can identify a capacitor by its two parallel lines with terminals connected on the two parallel lines. If a parallel line has an arrow, we call that capacitor a variable capacitance capacitor. While if it has no arrow crossing the two parallel lines, we just call it a fixed capacitance capacitor. When a capacitor is charging, so meaning charges are being deposited in the plates, current is actually flowing towards the capacitor. Conversely, if the capacitor is discharging, what that means is that current is flowing away from the plates. So these are examples of capacitors. So on the left we have fixed capacitors, and on the right we have variable capacitors. Capacitors are widely used in several electrical and electronic equipments. So we can find them in radio and TV systems on the tuner stage of these systems. You can also find them in cameras where they are usually used to charge um, a device that actually creates the photo flash of the cameras. You can also find them in pumps and refrigeration motors, where they help start these motors. You can also find them in electrical power systems, uh, where they're used to improve the operating efficiencies of these systems. And last but not least, you can also find them in computer systems where they're being used as memory elements. On the next video, we're going to study the relationship between the charge, the current, and the voltage on the capacitor.